Hello, Honors Algebra 2. Today we will be looking at some f of x and g of x's and performing indicated operations as well as stating the domain. This is something that a lot of people have trouble with on their next quiz, so hopefully this will help you out. So first of all, we have f of x is equal to 6 root x. We're actually going to change this next one to 2 root x minus 4 for g of x. Make the problem a little more interesting in terms of the domain. So, something to keep in mind is that we always want to determine the domain of each of these individual functions before we go ahead and figure out the domain of the entire thing at the end. So, this is a square root. I know that there can't be negatives underneath square roots. So, the domain for this guy is x has to be greater than or equal to 0. And don't worry so much about your notation until the end. We're just writing ourselves some notes. Same with this one, you can't have a negative underneath a root, so x has to be greater than or equal to 0 for that one as well. So we know for sure x has to be greater than or equal to 0, and then when we get our final product, we'll see if there's any extra information we need to add into our domain as well. So here we go, f of x minus g of x. We're just going to take 6 root 6 minus, and then you can probably guess the biggest issue people have is they just put this right here. And what they should have is parentheses. You are subtracting all of g of x. So you are going to have to distribute that negative and get a plus 4. And then we are just combining some like terms here. And you should end up with 4 root x plus 4 as your answer. Now, as far as your domain, x such that we know x has to be greater than or equal to 0 from both of these up here. Let's check down here, see if you have any fractions, because that will change things. We don't. X still can't be a negative, so it's just greater than or equal to 0. This will be different in our next problem because we are going to use the same f of x and g of x, but we're going to divide them. This one's a little weird. We're not going to rationalize at the end. We are going to end up with a root in the denominator. Don't worry too much about that. The focus on this one is the domain and the simplifying. Don't worry about rationalizing. So once you bring a fraction into the mix, you have to be careful because you can't have a 0 in the denominator. So it's really important to check that at the end. There might be some other values that we can't include in our domain. So let's put our f of x over our g of x. And please, please, please don't make Miss Bramer super sad and cancel these and say that it's a 3. We can't do that because we have subtraction here. However, you should notice that your bottom terms, you do have a GCF of 2. So we can take this 2 out, and you'll have this. Now you have multiplication. 6 divided by 2 is 3 root x over root x minus 2. And this we're going to leave. This is the part we're not going to rationalize. We cannot cancel these root x's. There is a minus sign here. This is your simplified form. And now we need to determine our domain. Remember, individually, x had to be greater than or equal to 0. No negatives. However, you also have this guy in the bottom here. So let's just see what happens with this. We know this bottom can't be equal to 0. So if I set this equal to 0, and some of you can just look at this and see what x can't be, but if we solve for x, you get a 4. So if I end up getting a 4 for x, root 4 minus 2, that's 0. That's bad. But over here, I'm saying, well, x can be anything greater than or equal to 0. Well, that's not entirely true. X can be everything greater than or equal to 0, except x cannot be equal to 4. Because if it's equal to 4, you have an undefined fraction here. You have a 0 in the denominator. So x can be anything bigger than 0 or equal to 0, but it can't be a 4. If it's a 4, you get a 0 in the denominator. Okay, so it can't be negatives and it can't be 4. It can be anything else. Even a 0. You put a 0 in the 0 in for x right here, you get root 0 minus 2. That's fine. Put a 0 in here, that's fine. You can have a 0 on the top. Can't have a 0 on the bottom. All right, let's try another one. All right, two new ones this time. F of x is 2x to the 1/5, and g of x is 8x to the 1/2. Notice there are no fractions, or excuse me, no parentheses here. So if you rewrite this, it's just the x that goes to the 5th root. Sorry, that was a little messy. And same with this. This is a square root of x with an 8 in front, not a square root of 8x. All right, so you have a 5th root. That's an odd root, which means you can have positives, negatives, 0, you can have whatever you want there. So this one's domain is all real numbers. You can put any number you want underneath that 5th root. This is a square root. You cannot have negatives underneath the square root because it is an even root. Same if it was a 1/4 power or a 4th root. You cannot have negatives. So this is greater than or equal to 0. All right, so now we're going to do f of x times g of x. And it's up to you whether you want to stick with the roots or with the fractional exponents. They are the same thing. Remember, you can go back and forth as much as you want. I'm going to use just the ones that were given to us. Okay, so I'm going to multiply my 2 and 8. And get 16. And remember, when you have the same base and you're multiplying, we add our exponents. 1/5 plus 1/2. You can take a second, type that in if you need to. Just for time's sake, it is 7/10. (16x to the 7/10). And remember, we cannot end with a fractional exponent. This becomes the 10th root of x to the 7. We check, 7/10 cannot reduce. You only have 7 x's. You don't have enough to bring any out because your exponent is smaller than your index. So this is your final answer. Okay, so now we check. This f of x could be whatever we wanted. G of x had to be greater than or equal to 0. So we need to consider both of those, and we need to look at our final answer. We don't have any fractions, so we just take a look at this. X cannot be a negative here. It still can't be a negative here because we have an even root. No negatives. So your domain is x such that x is greater than or equal to 0. Basically, you're going with the most restrictive. This one could be whatever, but this one's like, no negatives. So you need to make sure it works for everything. So there's your domain. All right, another fun division one. All right, f of x is this. G of x is this. You can divide your 2/8. And then remember, same base, we can subtract our exponents. 1/5 minus 1/2. And actually, 1/5 is smaller than 1/2. So, let me rewrite this. If we subtract, we are going to get a negative exponent. So instead, what I'm going to do here is rationalize. X to the 1/2, remember we want to complete a whole. So it'll be another 1/2. So now you have 1 x to the 1/5, x to the 1/2, we're going to combine those in a second, over 4x. Remember, these combine to 1x to the first power. So now these guys here, you can go ahead and add your exponents. 1/5 plus 1/2 and that is the same thing it was before in the other problem, which is 7/10. Let's come down here. And we still have an x down here. Remember, that was like our rationalizing. And now we're going to go ahead and just write that as a 10th root of x to the 7th over 4x. Okay, again, you only have 7. You need 10 to come out, so we don't need to worry about that. The 4 is not going to cancel with anything. No x's can cancel because this is under a root and this is not. So this is your final answer. Now, originally, the domain was all real numbers for f of x and greater than or equal to 0 for g of x. So greater than or equal to 0 is the more restrictive one. However, you still need to look at your final answer. So let's see. Yeah, it still can't be negative because you have an even root. But look down here. We're saying x is greater than or equal to 0. But now that we have a fraction, if x is equal to 0, you get an undefined answer. So we need to take away this equal to. And now x can only be greater than 0. Okay, it has to be greater than or equal to because you have an even index. But because we now have a denominator, we cannot have 0. It just becomes greater than 0 for your domain. Good times. All right, so there are a couple examples. Hopefully that helps you out. And tomorrow you will have another video to help you with our composition of functions and more with our domain. Okay, hopefully this was helpful to you. Have a great day.